Hi there, I'm a student and I've tried to summarize the whole of the modern physics in this one sheet for the purpose of revision. This one sheet includes almost all of the major formulas, the values which we have to learn, and the graphs which we have to understand and then also learn. It is basically a reviewing sheet or a cheat sheet, something you can see through just before the exam. To begin with, I'll start with the EM wave chapter. EM wave chapter talks about displacement current. The formula goes E naught, rate of change in flux. This is the magnetic flux. I know we all know this formula, but this is a cheat sheet, so we're trying to revise everything. So we've revised displacement current is E naught into rate of change of magnetic flux. This is one important equation also for the purpose of dimensional analysis, because they'll ask you the dimensions of E naught or B naught. You'll find it in relation with c, which is the speed of light. So c is E naught upon B naught. C is also equal to under root mu naught into epsilon naught. These two equations are important for numerical solving purpose. Now this is the revised version of the Maxwell's equation. We know the revised equation just only included this term, which is the displacement current, which is found only inside the conductor, and this is the normal current, which is found in the rest of the circuit. Their values are also same. I have not included this point here because it's a very general point and most people already know it. E dot dl is rate of change of electric flux. I have included this just in relation or analog of B dot dl, because E dot dl is rate of change of magnetic flux is an important equation used to derive induced electric field in different objects like loop. You've studied about this in the magnetism unit. So because we're revising B dot dl here, we'll also just look at E dot dl. It creates a memory inside your head, easier to revise things like that. Now electric field, magnetic field, and the direction of the electromagnetic wave, all three of them are mutually perpendicular and vary sinusoidally. However, there is no phase difference in between these three values. Phase difference is 0, mutually perpendicular, and vary sinusoidally. Now the direction of the wave can be found out from E cross B. Now it's just my thing, I remember it like that because C is E naught upon B naught. That gives us E naught somewhat a superior figure. So also during the E cross B, we will use E first, and during the E naught by B naught, the E naught will be at the upper end, like the numerator. It's not B naught upon E naught upon B naught, then E cross B. Just a way to remember it. You can have your own. Talking about radiation pressure, I think it's very convenient for us to remember it as a formula. Reflecting has double the radiation pressure than of non-reflecting surfaces. It's just I by C and 2I by C. It's something I just learned personally. Now talking about the energy density, which is simply energy upon volume, is half epsilon naught E naught square or half B naught square upon mu naught. The total energy will be the addition. Since will be the addition of this. This you will say half epsilon naught E naught square plus half B naught mu naught. I'm talking about the total energy density. Now since you must also be knowing that half E naught epsilon naught is equal to half B naught epsilon naught, so total energy you can write either epsilon naught E naught square or B naught square mu naught. This is very easy stuff. If you know basic maths, you'd understand what I'm saying. Average electron density, just replace the half term with 1 by 4. So total will be addition of it. When we add, we'll come with the figure half E naught epsilon naught E naught square or half B naught mu naught square. I'm talking about the total average electron density. Mind it, total energy density and total average energy density are two different terms. Now this is just a mnemonic I used to remember the electromagnetic spectrum. It says Gadi XUV in my range. Gadi is gamma rays, X rays, UV rays, U for UV rays, V for the visible range, I infrared, my micro, and range radio. And this is in the order of increasing wavelength. So it's Vibgyor. R has the maximum wavelength. So that was all about EM waves. I like to move on to the next chapter. Here it is, atomic number. I've just included these formulas because most of the others like the radius or the velocity or the energy are so cliched, and we have remembered or revised them, and we've revised them so often that we have it memorized. And these are some of the formulas we tend to ignore. So I'm going to focus on these ones. So it talks about angular node, which is okay. So before we begin with this, I'd say L is the azimuthal quantum number, N is the primary quantum number. Angular nodes, number of angular nodes in a atom is equal to its azimuthal quantum number. Like not an atom, you find it from the electronic configuration. I just got confused. Angular node is equal to the number of azimuthal quantum numbers. Spherical node is equal to n minus l minus 1. Add them up, total nodes is n minus 1. Just basic maths. The total number of spectral lines is a general formula, delta n plus 1 by 2. So delta n is basically n2 minus n1, the final minus the initial level of the electromagnetic spectrum. Not the electromagnetic spectrum, the final and the initial level of the atomic spectral lines. Now the angular momentum is equal to root L plus 1. L is the azimuthal quantum number, or delta n plus 2, where n is not the primary quantum number, n is the number of unpaired electrons in an electronic configuration. Please bear with me with using the same symbol, 3 ones. All 3 of them mean different things. This n in the total node and the spherical node means the primary quantum number. This n is the number of unpaired electrons in an electronic configuration, and this delta n denotes the difference between the spectral lines. That's all about the atom chapter. Also, this R is the Rydberg's constant. To remember the value of R is a tedious process, so I rather remember the value of 1 by R, which is an easy number, 912 Armstrong. I'd also like to clarify here that n plus 2 under root and under root L plus 1 are 2 formulas for angular momentum only, where L is the azimuthal quantum number I've written here, and n is the number of unpaired electrons. Moving on to the next chapter, which is dual nature. Right here, this is for a revision purpose, so I have only included the stuff which is very important and which need to be revised, right? So the stopping potential is directly proportional to frequency, and the photocurrent is directly proportional to intensity. This becomes important and worth mentioning because they'll give you graphs where intensity varies, so you have to show stopping potential is not dependent on intensity, hence stopping potential will remain constant when intensity changes. Also, photocurrent does not depend on frequency, so even if frequency changes, photocurrent will remain same. So this is a direct proportion. Photocurrent is directly proportional to intensity. Increasing intensity means increasing the photocurrent. And stopping potential is directly proportional to frequency. So increasing the frequency would increase the stopping potential in negative, because stopping potential is a negative potential. You all already know this. Talking about the Einstein's equation, it's easy stuff. You all already know it. This phi here is the work function. So work function also has the formula of h mu naught. Where this mu is threshold frequency, and kinetic energy is also equal to E into Vs. Vs is the stopping potential. These are 2 formulas. We know it, we're revising it. This is just a revision sheet, cheat sheet. There's a term called Compton shift. It's just an observational phenomena, Compton shift. The whole theory behind it is that after scattering of a ray, the lambda or its wavelength changes. So it changes according to this equation, h upon m naught c 1 minus cos theta. Theta is the angle with the horizontal, and c is speed of light, h is Planck's constant, and m naught is the mass of electron, rather the rest mass of electron. It would be mentioned in the question if at all they ask numericals about the Compton shift. Now there was this famous experiment of Davison-Germer. Basically what you'll have to remember is that maximum I was found at 54 volts and the lambda was found to be 1.66 Armstrong. This is observational. Now these are some really cool formulas which are very useful during numerical solving in the exam. For an electron, you can remember that the lambda will be, there are multiple distractions during the filming of this. My sincere apologies. For electrons, lambda is equal to under root of 150 by V. This value will come in Armstrongs. 150 under root is 12.27. You can either remember this, or remember both and use it according to the need. Like if you have 600, so 1 by 4, 1 by 2, easy stuff. Or you can use this. So according to the values given in the question, you can shift in between these two. That's just de Broglie. Lambda is h upon p, h upon mv. Mv can also be written as 2mk under root, and k is qv, which is basic stuff. That was all about the dual nature chapter. Next is the nuclei part. This is where I need this sheet majorly because I keep forgetting, and most people also, my friends also, keep forgetting the values or the formulas. This is one not tricky part, it's easy, but the point is if at all you can remember all the values and all the formulas and all the little things. So this is like the cream layer of this sheet. So begin with, the first thing I've written is 931.5 mega electron volt. This value, what should I say? When you calculate binding energy and you have the change of mass in the reactant and the product, right? And you have to find binding energy. You know what I'm talking about. These kind of numericals are found in the paper. So when you have the difference in the mass, you can multiply directly with 931.5 mega electron volt, or better multiply it with 1000 and just reduce that and take the closest option. It will be very little difference, 931 and 1000. There's very little difference. So you can take it as to be 1000 only. I know for some people who would be trying to learn something here for the first time or are freshers, this thing would be just going above the head. But this is a revision sheet. If at all you here to learn facts, please leave. I'm like, with all due respect, please save your time. Time is money. Okay, so if you have studied this chapter beforehand, you'd also know that density remains constant for almost all of the nuclei. It is a constant value, which is 2.89 into 10 raised to the power 17. You have to memorize it. They can either ask it directly in the form of a numerical, or it can be used in a multiple or the matching kind of question. This is R naught. Do you remember there was I'll come to it. R naught will come to it.